evaluate limit of sine x over x as x approaches to 0. If we simply plug in x equals 0 directly here, sine 0, and the value of sine 0 is 0 over 0. That means when we graph this function at x equals 0, we have a hole on the graph. That means limit still exists. So all we have to do is factor the top, factor the bottom, and that used to happen, right? But here we cannot factor anything, and when we had square root, we used to multiply by its conjugate and get rid of that, but that's not the case. But we just learned a new method called L'Hopital's rule. Whenever we have 0 over 0, then we can apply L'Hopital's rule. It's eligible for L'Hopital's rule. I'm applying that. I'm writing LH to indicate I'm applying L'Hopital's rule. So that is limit of this fraction is same as limit of this fraction, where we find the derivative of top on the top, derivative of bottom on the bottom. Okay, that's coming from the L'Hopital's rule. So derivative of sine x is cosine x, and derivative of x is 1. Okay, do not confuse with quotient rule or other rules of derivative. We are not doing that. By the L'Hopital's rule, we are finding derivative of top on the top, derivative of bottom on the bottom, and the limit of this fraction is same as limit of this fraction. Okay, now let's try to plug in cosine 0, which is 1 over 1, 1. So that's the final answer. Sometimes we might again get 0 over 0. In that case, we have to apply L'Hopital's rule one more time, or as many times as we need. But here, this cosine 0, which is 1 over 1, don't have to show. The final answer is 1. In fact, if you graph this function at 0, there is a hole, and that's at 1, in fact. And when x approaches to 0 from either side, the value is going to 1. You can check using a graphing calculator.